Assalamualaikum and greetings everyone. Welcome to my final year project presentation for FYP 1. My name is Muhammad FARHAN bin ZAINUDIN and I am a final year student from College of Engineering, Faculty of Mechanical, from University Technology Mara, UiTM Shah Alam. My title is Numerical Investigation of the Effect of Wind Speed and Solar Radiation Performance on linear Fresnel solar reflector of an eco-village in Malaysia. And I'm supervised by my lecturer, Dr. Al-Hassan Salami Tijani. Now, for the content of this presentation consists of first, introduction of this project, and the literature review of the project, the problem statement and the objective of the project, scope and limitation during the project, methodology the project, and also the expected result from the project. Generally, solar energy is sort of endless renewable energy that may be used to suit human requirement. This form of energy can be called renewable or pure energy, and it can be used in human everyday life. Today, the benefit of concentrating solar energy technology assisted considerably increase system efficiency. When subjected to solar radiation, the thermal performance of Fresnel lens or FLSC system may be assessed by calculating the system update heat gain. However, when developing new plant system, it was much safer for some company to use and invest in a well-known technology such as parabolic true collector (PTC) instead of solar Fresnel linear concentration. Based on Malaysia Energy Statistic Handbook in 2015, the generation of electricity, mainly in fossil fuel-based, consists of 50.4% natural gas, coal 38%, hydro 8.4%, fuel oil 1.1%, wind 0.9%, and photovoltaic or solar radiation 0.9%. Based on the past research journal and the study, most of the country had already developed their solar radiation system. For example, in Bangladesh, it was discovered that the increasing the temperature of the steam generator feed water can lower the quantity of the fuel that necessary to generate the steam for the electricity. While in Brazil, linear Fresnel collector LFC resulted in 50% of reduction in fuel use. And then, in India, using this form of energy is viable alternative for thermal power plant, saving 7 to 8% of the cost of fuel and lowering carbon dioxide CO2 emission into the environment by 62,000 tons per year. Next, we'll move on with the factor that may affect the performance of linear Fresnel solar concentration. First, on the first journal from M. Babu, which is the linear Fresnel solar concentration usually depend on the collector operating temperature, direct normal irradiation, the wind of the speed itself, and also the solar radiation incident angle. And from Lin Zhao on her journal on sustainable energy technologies and assessment, it is stated that the measurement of the energy flood density of the receiver are also important in order to evaluate and also observe the system efficiency of the solar radiation. And next, from WTZ on a journal Energy Conservation and Management, it is stated that the design of the different receiver cavity on the linear Fresnel concentration also play an important role parameter in order to enhance the performance of linear Fresnel solar concentration. Next, for the numerical analysis method. From Mokhtar Godbain in 2019 on his research, which is a numerical simulation of a linear Fresnel solar reflector, it is stated that they implement a transient numerical simulation on the linear Fresnel solar reflector. On configuration for this experiment, it is used that Fresnel solar collector with the same dimension as a Nova 1 from Novatech Solar Company, and also the method used for this experiment in order to gain the data is numerical solution and also the experimental analysis. And the result is that the optical efficiency of LFR or linear Fresnel reflector solar receiver has increased, and also the thermal efficiency also increased as a pressure drop. Next, we continue with the problem statement. Solar energy is a source of energy that depends only on the sun, so this makes it possible to produce electricity for thermal power plant. However, this application of using solar is still in an experimental phase and also an observation phase in order to use in today's technologies. With the problem statement, we came up with an objective of the project, which is to investigate the effect of the speed of the wind and solar radiation on the linear Fresnel performance, and then to analyze how heat loss can be reduced in order to enhance the performance of the linear Fresnel collector. Next, we continue with our scope of the study. The study of this project will be done at the Masa University with a 12 recommended average day for a month. Data will be taken, and the data will be run on the MATLAB software using a numerical solution based on the finite difference approach. After the scope of our study, we have to know the limitation of our study, which is to getting the detailed plan layout information about the location of the projects and also the data regarding the climate radiation of the study locations, such as global radiation, beam radiation, and also the speed of the wind and the ambient temperature of the location of the study. Before running an experiment or run the simulation data on the MATLAB, we first have to gather some information about the project, which is how it done, how it will going, and how we going to collect the data. And then we stimulate and generate the idea. After that, we accumulate the data from the previous study. In the same time, we also set up a coding to the MATLAB software. And from the coding, we collect the data gain and the result. We compare the data gain from the MATLAB software and then compare the data result from the previous study. And then after that, we can make a conclusion from our project. First, in order to solve the equation governing this problem, it was necessary to understand the physical phenomena, which are the best guarantee for writing a correct, simple, and also a suitable numerical problem, where this numerical method give very approximate solution. For example, we have thermal efficiency and also optical efficiency. In this case, the finite difference method in both was chosen to simplify and solve the equation in order to find the best solution for optical efficiency and also thermal efficiency of our project. Okay, this is the graph that we expected to get by the end of the project. which is, as you can see from the graph 1, this is shown that the change in our optical efficiency of the studied solar reflector. In this study, the optical performance varies between 51% and 53.7%, which is depend on the variation of the intercept factor of the direct normal solar irradiation, or we can call DNI. This factor is directly related to the geometrical dimension and the shape of reflecting mirror. And also it was found that the optical efficiency of all they studied is close, where it can be said that it fits at 53.7%. This value is very important for such type of solar concentration. And next, moving for the next graph, which is, it is remarkable that the evolution of thermal efficiency will follow the same profile as the optical efficiency. And that's the end for my presentation. And is there any information or any Q&A question, you can contact me at the below. Thank you.